Welcome to this lesson on the Model-View-ViewModel pattern, commonly called MVVM. If you have ever built a UI and found yourself writing endless code just to keep the screen in sync with your data, MVVM was designed to solve exactly that problem. By the end of this video, you will understand the structure, the flow, the trade-offs, and when to reach for it. As soon as an application has real interactivity, UI code tends to collapse into a mess. You fetch some data, then manually push it into labels, fields, and lists. When the user changes something, you read it back out and update your model by hand. The controller in classic MVC often ends up bloated with this glue code, making it hard to test and hard to change. MVVM attacks exactly this problem. Here is a way to picture it. The anchor on screen just reads what the teleprompter shows, that is the view. The operator formats and queues the content in real time, that is the view model. The raw incoming news feed is the model. The anchor never formats the feed directly, and the feed never decides how words appear on screen. Each role is cleanly separated, and the anchor works the same way regardless of which operator is running the teleprompter. MVVM splits responsibility into three components. The model holds your domain data and business rules. It has no knowledge of the screen at all. The view model sits in the middle. It reads data from the model, transforms it into a form the screen can display, and exposes it as observable properties and commands. The view is purely declarative. It binds its widgets to those properties and sends user gestures back as commands. Crucially, the view never talks to the model directly. Follow a single edit from the user all the way through the system. The user types into a field in the view. Because that field is bound to a property on the view model, the framework writes the new value there automatically. No manual event handler required. The view model validates the input and tells the model to save it. The model persists the change and signals that something has changed. The view model updates its observable property, and the binding layer reflects that update back to every widget that depends on it, all without any explicit refresh code. MVC and MVVM both separate concerns, but they do it differently. In MVC, the controller is active. It listens to the view, calls the model, and then manually pushes results back to the view. That works cleanly for server-rendered pages, where the response is a fresh HTML document each time. MVVM replaces that manual push-pull cycle with a binding layer. The view model never touches a widget directly, so you can instantiate it in a test, call its commands, and assert on its properties without needing a running UI at all. Reach for MVVM when your UI has real ongoing state, forms that validate as you type, dashboards that update live, or screens where many widgets depend on the same underlying data. Modern frameworks like Angular, Swift UI, and WPF are built around exactly this binding model. If your application is primarily server-rendered with thin client interaction, MVC is simpler, and the binding infrastructure buys you nothing. The decision comes down to where state lives. If it lives on the client and changes frequently, MVVM earns its keep. To wrap up, MVVM introduces a view model that sits between your domain data and your UI, exposing everything the screen needs as observable properties and commands. The binding layer does the synchronization work for you in both directions. That separation makes view model logic straightforward to test and keeps your view purely declarative. Choose MVVM for rich client applications with frequent state changes and lean on MVC when your state and rendering live primarily on the server.